I'll be talking about linear motion in this lesson. And in this topic, we're going to be looking at the different parameters that are used to describe the motion of a body. Whether you're talking about the motion of a body along a straight line, the motion of a body under gravity, we need to apply these parameters. And what are these parameters? Distance, displacement, speed, velocity, acceleration, and then the graphs of motion. And this topic serves as a basis for understanding and then be able to calculate and solve problems on linear motion. So, what is distance and what is displacement? So, I'll try my best to help you have or understand the difference, the distinction between distance and displacement. Now, the distance a body covers is the same thing as the total length of path. Is the length of the path covered by an object in its motion. And distance does not take account of direction. Understand? Doesn't take account of direction. So you can decide to go from here to your school, maybe covering a distance of 200 meters. You can also cover the same 200 meters moving from here to your church or to your friend's house. So when we talk about distance, we are just talking about the number. We are just talking about the amount of ground that the body has covered in the course of its journey. And that's why distance is a scalar quantity. A scalar quantity has only magnitude. So the unit of measurement of distance is the meter. We can also use kilometer. So somebody can cover a distance, for instance, a distance of 50 meters, you know. So the 50 there is the magnitude, is the size, is how far, so to speak, the person has gone from a starting point. So it has only magnitude. And then distance can also be expressed in kilometers. One can cover, or have people talk about traveling or covering a distance of 1,000 kilometers or 200 kilometers, as the case may be. So you should know that a kilometer is equal to 1,000 meters. So with this, you can do your conversion. So if you have a distance of 500 meters, of course, you know that this will be equal to a half a kilometer because 1 kilometer is 1,000 meters. So distance is the length of path between 2 points from one point to another. And we calculate distance by using the formula. Distance is given as speed times time. Speed multiplied by time. And then displacement, on the other hand, is the distance a body covered in a specific direction. And displacement is a vector quantity. Recall that a vector quantity has both magnitude and direction. And then in physics or in mathematics, we always use a line segment with an arrow to represent a vector quantity. The length of the line corresponds to the magnitude of the displacement vector, and the arrow edge gives the direction the vector is acting. So a displacement is a vector quantity, or displacement is a vector quantity. It has both magnitude and direction. The symbol of displacement is S. And one thing about displacement is that it can have a positive value, it can have a negative value, it can also have a zero value. Distance is always positive, and so on and so forth. So we're going to look at this distinction again carefully between distance and displacement. Let's say that this is where you are, this is where you live, this is your house, and then this point here is your school. Yes. And the only path available if you must go to school, if your driver must drive you to school, you must go this way, this way, this way, and then eventually to your school at point S. And this is the only path available because when you are driving through the highway, there are structures all by the sides of the road. Maybe this is a filling station, maybe this is a mall, a shopping mall, maybe this is a church, and so on. And it's not possible for you to drive along a straight line from your house to your school. You have to follow the path available. And let's say that this path length is 50 meters, that is from here to here, and this is 100 meters, then this path length is 200 meters, and then finally this path length is 20 meters. So if you must drive to school from your house at H to your school at point S, you must cover a total distance of 370. That is this plus this plus this. That gives you a total distance D of 370 meters. That is distance. That's obviously distance is a path length, the length of path covered. How much ground have you covered as you move from one point to another, expressed in meters in this case. So that's an example. And another word for distance. Distance also means perimeter. Recall that perimeter is always defined as distance around a shape, the perimeter of a triangle, the perimeter of a rectangle. So it is distance around the shape, you know. And then distance, another word for it is circumference. Like for instance, the circumference of a circle is the distance around the circumference. Let's take for example, a student starts its journey from point O, this point here, and it moves a distance or a displacement of 10 meters due east. Then let's say this is the point, maybe to the school, 10 meters from his house. And then after school, he decided to go and check on his friend, and then had to move due south. Due south. No, we have a cardinal direction like this. I have my north, I have my east, I have my south, and I have my west. So which means a displacement due south is this way. Let's say a distance of 5 meters to see his friend. And then after that, let's call this F. Then decide to walk to another friend's house, maybe to check on another friend who did not come to school, living at point B. Then after that, you have to walk a distance of 5 meters back home. From here back home, a distance of 5 meters. So you can see here that it's very, very clear that this boy, this student, must have walked a total distance of 30 meters. That is 10 plus 5 plus 10 plus 5, 30 meters. But what is his displacement when he's back to point O, his starting point? Now, to get his displacement, we have to recall I said displacement can be given a positive sign, can be negative, can be zero. So displacement due east, we can say let it be positive. Displacement of the boy due south, let's call that negative. Displacement of the boy due west, we can call that negative. And then displacement up north, due north can be positive. So due north is positive, due south be negative. So if due east is taken as positive, then due west must be negative. So by the time you add them together, plus 10 minus 5 minus 10 plus 5, the total displacement of this boy is 0. So you can see that when the body starts its journey from a point and then is back to the same point it started from, its total displacement is 0. So displacement this time means how far a body is from a starting point. It's just like a total change in the position of a body in the course of its motion. That is displacement. But distance is just the length of path. How much ground has that object covered during its motion? That is distance. So this example clearly shows us the distinction, the difference between distance and displacement. And again, if maybe the path available for someone to move from a point O here, maybe to a point B, is just this semicircle. Somebody has to walk through this semicircle to go from point O to point B. Now, what's the distance walked by this person? The distance walked by this person is the same thing as the length, the perimeter of the circumference of the circular path. Now, if the circular path has a radius r, then for circumference, it is 2 pi r. So we use that to calculate the distance walked by the person. If you had to go from point O, go past point B, and then back to point O. So when it starts from point O, walk around this circle, and then back to point O, it has walked the total distance equal to the circumference of the circle. But if you walked just from point O to point B and stopped there, then the distance walked becomes a perimeter of the semicircle, which is 2 pi r divided by 2. That gives you pi times r. So when the radius is given and pi is taken, you take pi 22/7, you can calculate distance walked by this person. Or let's say that you have a path or someone, Mr. A, left his house at this point and probably walked to a shopping mall at this point. It's a shopping mall, a distance of 100 meters to get some stuffs. And after that, you remember that you had to get something around here. Let's say it's a different supermarket here at point S in order to get something, and the distance from this point back there is about 150 meters. Now, when this Mr. A arrived at point S, what is the total distance walked by this Mr. A, and what is his displacement from the starting point? So, what's number one, the distance walked by Mr. A, and then number two, what's the displacement? Displacement of Mr. A. Most times they say from his starting point. That's point H. From his starting point. Okay. Now the distance walked is just the total length of path from point H or to point M and then back to point A. So that is 100 plus 150 meters. That gives you a total distance of 250 meters. That is distance, that's the length of path. But the displacement now of Mr. A is just 150 minus 100, or the other way around, 100 minus 150, that gives you 50 meters. Why is it so? We can decide that let distance walked, or the displacement of Mr. A from H to M, let it be given a negative sign. That's direction due right. Now, when he's now walking from M to S, the direction has changed. He's now walking in the direction opposite to the direction he once walked when he was going from H to M. So we can give the direction positive. So the displacement is the difference between, it's just the sum of these two, but just that this has a negative. When you add a positive number to a negative number, of course, the result is just the difference between two numbers. So his displacement from his starting point is just 50 meters. And then lastly, suppose you are told that a student started from point S and walked a distance of, let's say, 6 kilometers due east, and then maybe to this it's a physics teacher's office, and then he decided to, after he had submitted his assignment, he decided to go and see his friend in his classroom. Let's say he had to walk a distance of 8 kilometers due south to see his friend at point C. Now, that student is at point C. The question is, and then what is the displacement of the student from where he started from? The total distance walked by this student, of course, that will be 14 kilometers. 14 kilometers gives you that distance walked by the student. And then his displacement is just a line that connects the point S to point C. Displacement most times is the distance covered by a body in a specific direction measured along a straight line. Since displacement has to do with direction, then we must measure the magnitude along a straight line. So the straight line that connects where the boy is, where the student is, to the point he started his journey, his motion. This straight line represents or gives the magnitude, the size of the displacement of the student. The direction is the angle that the displacement vector of the displacement line makes with the horizontal. Theta is the direction. So by this forms a right angle triangle. So we can use Pythagoras theorem. By Pythagoras, we have a displacement, may call this S displacement squared is equal to 6 squared plus 8 squared. That gives me 100. My displacement squared, that is 36 plus 64. So that my displacement is just square root of 100, which is 10 kilometers. So the boy's displacement in magnitude is 10 kilometers from the starting point. From the starting point. And then the direction, we can use tan. So because it's a right angle triangle, tan theta gives me opposite, that is 8 over 6. That gives me 1.33. If we divide that, so that the direction of theta is tan inverse of 1.33. That will give me roughly 53 degrees. That's his direction. So that the boy's total displacement is 10 kilometers. What's his direction from his starting point? This is the boy's direction. Okay, so if you want to specify the displacement, that is both the magnitude and direction, the boy is now southeast of his starting point. So his displacement, in the direction of his displacement, is southeast of his starting point, which is 53 degrees east of south. So the next video we shall continue from this point.